Okay, we have done distance and displacement. So now, as we have seen, distance can be equal to displacement, but distance cannot be less than displacement, as we have discussed in the previous examples. Now take one example related to distance and displacement. First one is, suppose you have taken, this is the center, I am taking an example in a circular path, this point O, any object is A and it is moving in a circular path like this, radius is R. So, when the object is at A and it is going to the point B, this angle is 90 degree, it means first quadrant it is covering. So, here this is R, obviously this is R. So, this is the length of the path which has travelled by the body. So, in this case you can write distance is equal to basically 1/4 of the whole circumference. So, that you can take 2 pi r upon 4, that is pi r upon 2. So, this is your distance, but displacement, as I have told you, this is the shortest distance between initial and final position. So, this is known as displacement, this line here. This you can find out by Pythagoras theorem here. In this case, this is here r root 2. So, the displacement is equal to r root 2. But suppose when the body is coming to the point C, here just opposite to A, diametrically opposite, what is the distance? You can do, this is orally here, this is the length of the path, this whole thing we can take as a length of path. So, this is called distance, this is actually half of the circumference, that will be equal to pi r. Now, what is displacement? This is r plus here, this is r, so the displacement is 2r. Similarly, you can find out the displacement when the body is at D and when the body is reaching to at A. Suppose the body is completing one revolution reaching at the point A. So, when the body is coming at A, the distance is equal to 2 pi r whole circumference, but whereas the body has come back to the original position. So, final position and initial position both are same. So, the body has got displacement 0. So, this is the example where the distance and displacement we can discuss easily, but here you are seeing here simply the length of the path we are taking as distance and the shortest distance between initial and final position we are taking as displacement. So, after this distance and displacement, we come to the point here, like here we was taking along the x axis. So, just see here, according to the coordinates, what type of the motion we study. So, actually there are three types of motion we study. One is called one dimensional. See here, in one dimensional motion, only one coordinate of the frame of reference changing. Suppose the body is moving either only along x axis or only moving along y axis or moving only along z axis. If the body is moving and only one coordinate is changing at a time, we call it that is a one dimensional motion, right. Suppose if I am moving along a straight line, cycling here along a straight line, your motion is a straight line, that is a one dimensional motion. But if the body is moving in a plane where its two coordinates are changing at a time, maybe x and y together, maybe x and z together, maybe y and z together.